Hello, now let us start a new topic, sign convention in spherical mirror. Okay, sign convention here particularly for concave mirror we will study. Please be alert, this is the important topic. Sign convention. Draw the concave mirror. Now you will have enough practice to draw this concave mirror and their cases. Pole, focus, center of curvature. Suppose I place an object AB beyond C. You know that first ray is parallel to principal axis, and then after reflection it passes through F. Second ray suppose directly pass through C. Here it incident and then come back towards this. So here an image is formed which is real and inverted image. We call it A dash B dash. See, sign convention. This rules that how to draw cases of spherical mirror or lenses. Okay, this rules is derived by mathematician known as René Descartes. Have you heard about it? In 9th standard, you have heard about it. In coordinate geometry chapter, Cartesian product were there. So here, this sign convention, it is called René Descartes or Cartesian convention. See, the first rule to draw cases anywhere in the world, you have to draw, not you, but every person can draw with the help of this rule, Cartesian rule or sign convention. The first rule is what? Always place your object left side of the mirror or lens. Place the object on left side of the mirror or lens. Okay, so in lens also the same rule is there, so we don't repeat it. Is it okay? Place the object means object is placed always on the left side of the mirror or lens. Now see, think that this principal axis is your x-axis on the graph paper. P is called origin. The coordinate of origin 0, 0. So if you draw y-axis, it passes through P like this. This is x-axis. Compare with x, y. Here it is x dash, here it is y dash. Okay? So if you compare, means if you draw these cases on the graph paper also, then you can draw, you can try it also. મજા આવશે બહુ બધી જ કેસીસને ગ્રાફ પેપરમાં ડ્રો કરો. બરાબર છે? ટાઈમ પાસ બી થઈ જશે અને એક સારો આઈડિયા બી આવી જશે. So if you draw this on the graph paper, then you can derive the another rule also. Always place your object upright, means towards positive y axis. You know that this is positive, this is negative, here it is positive, here it is negative. So always place object upright on the principal axis. Or called towards positive y axis. Okay? Now see, if object is placed always upright, then we can derive that object height, we call it h, object height is always positive. Object height is always positive. So what about object distance? From pole to object. This is called object distance. Object distance is always denoted as u, small u. If you place your object left side of the mirror or lens, then we try to move towards negative x-axis. So object distance always measure from pole to object is always negative. So we move towards negative direction. So you can say that object distance which is denoted as u, small u, is always negative. Value of objective distance, value of u is always negative. Means in the numerical, suppose it is given that object is placed at 10 centimeter from the concave mirror, you have to take u equal to minus 10, don't take plus 10, because object distance is always negative. Given is plus, but you have to take minus because it is object distance. So please be alert here. Now see, what about image distance? If image distance is fall on the same side of the object, then it is always negative. And if it is falls on opposite side of object, then it is always positive. So image distance depends, maybe negative or positive. You know, negative is possible only when it form on same side of object, and positive is possible only when it is formed on opposite side of object. Opposite of object, side of object. Okay? Image distance, it is denoted as small v, not the big capital, it is called small v. Now what about focal length and radius of curvature? Remember, for concave mirror or lens, if there is a word concave inside, cave means, then its radius of curvature denoted as capital R, and focal length denoted as small f, always negative. Remember, this is important for numericals. Concave mirror, for any concave mirror or lens, radius of curvature and focal length are negative. Or remember, if radius of curvature is negative, focal length is always negative. And for any convex mirror or lens, radius of curvature and focal length are positive. So you have to learn this, you have to write it. It's a 2-mark question, which is also important for numerical, also important for objective also. So write it, that's it.